Good morning. Good morning, everybody. I see that you're entering the conference. We are already 20 people attending now. Thanks for coming to this webinar organized by Ocrim and Molitecnica, two historical brands in Italian milling that since a couple of years are working together on the nixtamalization, corn nixtamalization process, merging the long experience of Ocrim in milling technology and the big experience of Molitecnica in the corn nixtamalization process. The webinar today will be the duration of 1 hour, and at the end there's going to be a questions and answers section, and you can also write your questions or comments in the question and answer section of the webinar. So we will receive a message and we will be answering at the end of the presentation. I introduce myself for those who do not know me. My name is Andrea Schintu, and I am Ocrim sales manager for Latin America and Spain and Portugal. I've been working in Ocrim for more than 15 years, always in the sales department, and I've been attending all the markets of the Iberian Peninsula and Latin America since 15 years. So this was my introduction. Now I pass the mic to Rodrigo Ariceaga from Molitecnica that will introduce himself and start with the technical conference. So enjoy the webinar and we'll speak later. Bye-bye.
Thank you, Andrea. Good morning to everyone. I'm quite excited to see a lot of the attendance today. As Andrea mentioned, my name is Rodrigo Ariceaga. I'm basically the North America sales manager for Molitecnica, and as Andrea explained, we do have a partnership that it has lasted now for 2 years, joining the efforts into the Nixtamalized or specialized milling technologies across the world. I oversee basically from Mexico up to Canada, specifically United States, but I also have the opportunity and the privilege to act as a technologist and give support to customers and assistance to the rest of our sales team. Molitecnica has been in the industry for about a little over 55 years. And about now, close to 15 years, Molitecnica had the vision of enter this unique market that we obviously are gonna aim for to present today on this webinar. Obviously, I will look forward to see some of your questions and try to help answer as much as obviously I can. In other cases, if there's a deeper requirement of information, you saw an email earlier, and we're probably going to display it again at the end for specific questions, or if you need somebody from the sales department or technical support to help answer some of these inquiries. It is my pleasure to be here with you, and I do thank you for your time and attention. I'm gonna try to explain, obviously, two parts of the nixtamalized corn flour. processing. Basically, the process alone, what it has to do with the technology and the steps to follow for the process of transformation. And also gonna try to talk some about the benefits of nixtamalization in comparison with a lot of the other processes that you might be more acquainted to specifically. First and foremost, I want to just kind of talk a little bit about corn so we can start with the base of, okay, what are we talking about? And corn, obviously, as you might know, or a lot of you might already know, it's basically the leading cereal for close to 20 years now. Corn, it's perhaps the cereal or the grain that the world has found more applications than any other grain out there. And we can go, you know, and you're going to see some of this information ahead. Some of the applications for industrial usage, for food, for feed, for fuels even, and so forth. So obviously, as being the leading or the king of the cereals, we're going to try to steal a bit of that portion into what is known as nixtamalization. Before anything, obviously, I'll explain, you know, the complexity of the corn alone, and a lot of you might already know this. And basically, there's three main components. You see four in the screen, obviously, and there's actually a fifth one that is the peak or the bottom of the kernel. But mainly, the corn is based on endosperm, which is all the inner starches. Basically, we have obviously the corny or the hard endosperm and the floury endosperm in the outer layer or the outer sides. This sums about 82% of the corn itself. It might vary by varieties or colors. But in the overall, you're looking about 80+% of endosperm. The other component is basically pericarp that you see on this slide broken down in two layers, the outer layer and then what I call the inner layer or aleuron. Basically, both of them obviously have the insoluble and insoluble fiber or dietary fiber, has the minerals, you know, the phytic acid, and in some cases, such as blue maize, antioxidants. In red maize, you'll find that it has also flavanols and so forth. And lastly, as important for the complexity of the corn is the germ, where you will find the oils or the lipids, the polyunsaturated fatty acids, some other minerals, antioxidants, and vitamins. So in other words, this little grain or kernel is loaded up with nutrients that obviously are not easily accessed or available for human consumption as it is on its original form. And we'll get more into detail as we move on. Obviously, as a rule of thumb for any industry, you know, if you have a good quality corn, genetically speaking, or the complexity speaking, and it has followed good practices from the production side, the agricultural side, good handling and storage conditions and everything, it's meant to give you a quality product on their efficient basis. Give you a quick snapshot of what the corn usage is on the US alone, just so you understand how wide of applications there are today as far as corn usage. There's about 35% of the corn used in America for feed. There's another 13–14% of it for exports. As I said, the US is the largest corn producer worldwide. So there's a lot of exporting going on to support other countries in need of this. Then we have a good portion of it, 35% to ethanol or fuel production, and another 8%, roughly speaking, for distillery grains or dry distillery grains. Some of it you will find from the same ethanol production, and some of it you just dedicate as a whole for specialty industries. And then lastly, you have what we know as as another variant or derivatives of the corn alone. And we go into high fructose corn syrup, starches, modified and unmodified. We have also sweeteners, cereals, others, beverage, and so forth and so on, as well as down to the last, basically 1% of for seed purposes to continue growing on the following seasons. Basically in this last part or last segment, this is where we really emphasize the milling processing of the grain. So so perhaps we start kind of breaking down the segments into what we go on the milling and opposed to just using as a whole for feed and the other ones as we consume this corn. Out of the milling, the majority of it goes through what we know in the industry as wet milling. And wet milling, it's a little complicated process that it's a water intensive and uses a lot of hydrocyclones and centrifuge force to aim for the separation of the components. And then you start going into, as you see on the screen, for high fructose corn syrup, sweeteners, and so forth and so on. So basically, you break down the kernels into different applications, and you start creating, a portfolio of byproducts, if you might. We're not really gonna dive deep into the wet milling this time. We're basically gonna try to focus, and the main goal is to explain the nixtamal. But the next segment goes for what we know industry-wide as dry milling. On the dry milling, I will also try to explain a little bit of it so you understand better the difference between one another one, but by far the dry milling is the second stage or sizing the segmentation of all the purple side that you see on the screen, as important. Within that same dry milling, you also have a very small segment of what we know as a pre-cooked process or pre-gelatinized products, whether it's cornmeals or flours. It's just an extra step that I will aim for to explain also in the next few minutes. And obviously, lastly, we have that one the process that is known as alkaline cooking processing, better known as nixtamalization. And as I said, that's the goal today to walk you through some of the highlights, the process, and the key components of it. First and foremost, I guess a lot might be wonder what does nixtamal means or nixtamalization. And nixtamalization is basically an ancient recipe. Our ancestors, the Aztecs and the Mayans, used this recipe in order to produce or process their foods. And the word alone came from the Nahuatl, with composed of two words, basically the nextli for ashes and the tamale or tamal for tamale. So basically, that's the name that it was given ever since. It's a process, by far, I think, the oldest in the processing of the corn itself or alone, and it has been on our culture for over thousands of years. So basically, we see that the nixtamalization is basically, as I mentioned, a recipe. So what is that recipe all about? And you'll find out that there's basically the main 5 factors that has to do with the nixtamalization, starting with the corn, with the water, with the lime, and then we have temperature and time. So basically 5 factors that you cannot accomplish or achieve the nixtamalization if you're missing either one of them. So if you don't have water, it's not going to be nixtamalization. If you don't have temperature, it's not going to be nixtamalization. You have to control the time in order to have a proper nixtamalization, because obviously time is an essential factor for the cooking process. If you underdo it or overdo it, you might want to think about it as let's say the Gauss bell. You have a peak of efficiency, and then there's a degradation of the same components, starches, and fiber, and then you lose that optimal cooking that you're aiming for. And then throughout this process, you obviously are going to find the main characteristic of this process all along, which one, and by far one of the most important, is that the increase of nutritional values. Like I said earlier, there's a lot of hidden nutrients in the corn or on the kernel that are hardly available for human consumption specifically, and that are not released unless we use this process altogether. So look at it as nixtamalization being like the key component in order to release and give access to all of these goodies behind what's in the corn. There's obviously a great flavor and aroma behind this process. It's very unique. A lot of the people throughout the world know that nixtamalization is more known and based on the staple of the Hispanic diet, called the Mexican diet or Central America and so forth. But basically it has that aroma that pretty much and taste that pretty much everyone likes when they get to have that experience. Other great characteristics, a lot of the mycotoxins are reduced or eliminated because of the same process. We're cooking, we're using temperature, we're using lime, we're using water. So basically a lot of these mycotoxins that are mainly on the outer layer, they're being disrupted or eliminated. Also, the alkalinity helps on the dissolution of the same fiber or hemicellulose, which also give that effect of gums. We call it natural gums in the dough when it comes to it, and you can only achieve with the presence of the lime itself. So it is very important component. Some industry or some of the industrials, they call it an ingredient. Some others, we call it a process aid. So it works throughout the cooking, but not necessarily you want it to stay there on the following steps. So think about it as just a process aid, as well as you use water per se. Some of the corn oils are broken down as emulsifying agents, and they give that characteristic and unique effect or binding effect that you have on the masa dough. On the wheat, you will see it as the presence of the gluten in the flour. So obviously you have that elasticity resistance. Pretty much you accomplish that in the nixtamalization for being a nixtamalization process. If you were to just try to cook the corn, you wouldn't be able to achieve that binding effect and that playability on the dough or on the formation of different products. We also have the availability of the niacin, which is an essential amino acid. And a lot of this insoluble fiber, it becomes basically soluble and acceptable for the human consumption, including the nutrients behind it. I'm gonna switch a bit and try to explain the dry milling process. So we're gonna take a couple of steps back. Now we know, we pretty well understand, and I hope obviously that, that I give you a good intro of what nixtamalization is. So before we dive into the steps to be followed on the process, I'm gonna explain a bit of the dry milling process. And mainly a lot of you might know the dry milling. That's where we accomplish a lot of the products that you know in the industry for beer grades, snack grades, dry flours or cornmeals and so forth and so on. The main two components of this process, it's obviously the first one being the germination. You basically go through a tempering stage. You basically moisturize the kernel to, let's say, 20%, roughly speaking. And then you rest it to help that outer layer softens off and try to detach on its own natural way from the kernel. And then you go through a process of removal of the germ and the fibers. In this particular case, basically you use the germinators, as we know in our industry. when it comes to technology. And there's also some other steps that you can follow within, which are probably purifiers. If that byproduct that you obtain by separating the first attempt of separation of the germ and of the fiber, you might still have some endosperm attached to it. So you go through a purifying system to try to clean that up and recoup as much of that starch back into your main goal, which is have all the endosperm clear of anything else. And the next portion of it is just basically the refining. So once you have the corn, the peel corn, basically, you go through a first break, and then you start going through sifting process and continue following with other roller mills, trying to find the proper granulation that you're aiming for. And from there, obviously, you have the pneumatic system to convey your products throughout the line, throughout the cycles that it has to take, all the way to the end beans or end tanks for packaging or whatnot. Basically, those are the two main components of the dry milling. If we try to go to the pre-cooked milling, think about it as if you come in and you break that previous process in two, you separate them, you have the degerminating on the one side, which I already explained, and you also have the refining portion on the other side. So think about if we come on the center and we add up an extra stage where it has to do with the pre-cooking or pre-gelatinization, gelatinization, I'm sorry, of the starches, or the grit itself, as we call on the previous one. We're gonna go through another same as tempering. You're basically gonna condition the starches, try to moisturize. You're gonna let it rest as well, and then you're gonna run through what we know roller flakers or steam flakers, where you're basically gonna form these flakes, and you're gonna run typically through a horizontal dryer system, a conveying system that it's also known as fluidized beds, where you're basically gonna take most of that moisture away. If you bring up to, let's say, 24, 28%, 30%, whatever the case might be, you're gonna aim for to bring it back to between 11 and 13, as you wanna continue dehydrating unintentionally on the rest of the process. And then you go to the refining part. You're gonna go through the first break. You're gonna try to break those flakes into little pieces, and then start running through your sifters. While going into the sifters, then you're obviously gonna be going through the roller mills and try to aim whatever specifications of granulation that you might have of your end product. From there, again, it's just compound of pneumatic systems to convey the product throughout the line on the cycles that it has to take, or going into the finished product beans or tanks for packaging, or whatever the destination might be from there on. And then we obviously now I'll show you a quick snapshot of the nixtamalization flour process, how the typical nixtamalized might look like. As you can see, obviously, it's nothing like what I already showed you on the previous slides. It's a little bit different, different complexity, and different equipment, different technology. That's kind of why it makes it more unique to its application. So on the flow chart of the steps to be followed, we have the receiving of the clean corn. We're just gonna focus on clean corn. We're not gonna spend time going through cleaners and sorting, color sorting, and all of those type of technologies. Basically, we're focusing on the processing alone. So when we have our clean corn, we go into our cooking system, where, like I said before, we add water, hydrated lime, and then obviously we control with time and temperature. Once we achieve the the corn to the cooking stage that we're looking for, that's when we then call it nixtamal. Once we have the nixtamal out of the cooking system, we're gonna go through a washing step and then rinse it out. We try to eliminate all the external moisture or water to the corn, because we really don't need that anymore. All we care is to have that physical-chemical reaction to break the fiber, not necessarily off of it, but just basically have the opportunity to have the moisture and the gelatinization work its way through into the corn itself. So how does that look? That on that segment alone, you can see that from our corn silo tank, we fall through into our continuous cooking system. Obviously, we control with a flow meter in order to be able to maintain consistency and quality of the production. You have to have points of control. So obviously, flow meters are by far the best solutions there are. You know, a lot of the all the companies or small systems, they just try to adjust with gates, but obviously you're best controlling all the recipe, and corn itself, you have to keep good track of what's going through so you can efficiently utilize the time, the temperature, the lime content, and the same usage of water. Once you go through the system of cooking, you have to pull out through you know, unloading auger, as we call it. We're going through our washer system. Basically, we rinse from the water of the cooking system. It's known as actually nehayote, which is water contained with ashes, basically on the Nahuatl as well. But then we go through the washing system. There's different ways to wash your kernels. You can do right on the spot, or you can have a different separator tank of, we call it under immersion. And you know, there's different ways according with what in this case the industrials are looking for, not only as far as efficiency, but also as how thorough they want to wash their kernel after being cooked. And then from this step, we move into the next section, call it stage number 2. You remember the first part we already talked about, and now we go into it. We transport our nixtamal into what we call steep or rest time. And I call it the steep because obviously there's some of the industry today that still submerge or maintains the corn submerged in the same water that they cook it with. For those cases, you're not talking about a continuous cooking system. You're basically talking about a batch cooking system. Basically, big kettles where you fill them with water, you heat them up, you add the lime, and then you add the corn, and then you just keep an eye on your watch. That's basically the steep batch system. Same way goes to the resting or the steeping time or the resting time. Basically, you just hold it on it. A lot of the industry in small communities, they hold overnight the corn, which is not necessary nowadays with all the technology. From going 12 to 18 hours of resting, now we do and accomplish basically the same in about 4 hours tops, 4 or 5 hours tops, time. So, but you know, from that stage, basically we accomplish several things. One of it, and by the way, I didn't mention, aside of resting submerging water, we also rest on dry. So basically, from rinsing previously the corn from the cooking system, we just hold it on a tank, and we aim to try to maintain it in about, let's say, 70 Celsius degrees, basically rule of thumb. And if you can hold it there for about 4 to 5 hours with, temperature that is going to start declining over the course of the time, obviously, will give you the accomplishment that you're looking for. What are we looking for on the resting? We're basically trying to homogenize the entire corn, or the volume of corn that is being processed. We're helping soften a lot of the corn that it didn't achieve any gelatinization. The internal part just loosens up a little bit, or basically softens. It just becomes more playable to get through the rest of the system per se. And obviously there's a completion of the physical chemical reaction too. So a lot of the reaction that we're aiming for happens on the cooking, but the resting has as much as importance for these good quality products to be accomplished. Then you go into the first grind, you dehydrate. After you have dehydrated, you try to cool down your products, so then you can continue the rest of the processing. That part alone, after we unload the nixtamal into the rest bin, in this case we see a dry rest bin, basically not submerged in water anymore. We're just going to hold it there for that period of 4 to 5 hours. In most of the cases, there are, by the way, some products that only hold or are required to be held for half an hour, 1 hour, low absorption flours that I'll try to explain here shortly. But typically the aim is to stay around the 4-hour period. After that has been accomplished, we go into our first grinder. In this particular case, our technology is based in hammer milling or hammer mills, which it's by far one of the most efficient ways of grinding on an industrial scale. Obviously, there are other technologies that come from also our ancestors, such as stone grinders. There was an evolution to metal plate grinders. And there's some other that has to do with friction as well. But then again, hammer mills by far are the most efficient ways to really disrupt that sizing into the particles that we need. And that is what also makes our dehydration an efficient process. If you see on this drawing, obviously we're showing basically a flash drying system. So we're talking 2 to 3 seconds retention in the chamber or in the whole channel before it gets unloaded on an unloading cyclone to then be released into another step of what we call the cooling. Obviously, after it's being cooled down to call it as close as possible to room temperature, then we can continue our process starting with segregation by particle. After we start the process of segregation by particle, we're going to have, just like any other sifter, you have what's good and what is not good as far as granulation goes. What's not good, obviously, is going to go to a second mill or remillers, pulverizers. There's also different technologies available. We also obviously recommend the hammer mills, but at the same token, there's blade mills, as we know, or pulverizers that are by far, probably the leading efficiency-wise, as we know. And then obviously there's a cycle back into the sifting process. In some cases, some technologies follow by different sifters. So you have the sifters for first grinding, as well as now you have sifters for the second milling or the second stage. And in some other cases, they can combine them and just create that loop on the second stage. Was not accomplished granulation that you're requiring. You want to go through the remilling back into the same sifter. So depending on the case, depending on the capacity that you're aiming for, you're going to be able to finally release that product into the particle sizing that you're looking for. From there, obviously, you're going to have the direction to finish flour beans, which then it will follow by packaging, if that might be the case. That last part is basically, obviously the main components is the pneumatic transportation, the hammer mill or remiller or pulverizer, and the second pass through the sifter that I showed you on the previous slide. And obviously, we also recommend having or using the technology for flow meters, because it is important to also keep track of your output. We're tracking and controlling the input going into the cooking system, but you also gotta keep a good measurement of your output. Otherwise, you're only relying on the one side, but you don't know for sure how many losses you might have on the cooking, on the emissions, on the equipment failures, leaks, or whatnot, and the same that is being stuck on the system all along. So it's a good indicator and part of simplifying the control and helping make these systems the most automated as possible, for the sake of cost of labor and whatnot. So a flow meter, it also gives you that great advantage of maintaining your line properly balanced. And voila, that's basically how you see the process all together again and all combined in one basically snapshot. Like I mentioned before, the main factors, and I call 3 of them. Obviously, every step is important, but what I call the key factors will start basically with the cooking, basically the nixtamalizing. And the proper word is nixtamalizing, not cooking, because there are many technologies for cooking, but not necessarily nixtamalizing. You got to remember the 5 factors that I have mentioned twice already, and that area is it's by far the key step in order to be able to have a good output. If you do not control and maintain a good level of accomplish in that step, basically there's very little you can do down the road to fix or accomplish. A lot of it you can probably accomplish on the second step that I call the resting, basically. So if you undercook, you might hold it a little longer and you might be able to correct some of it. But in case that you overcook per se or over nixtamalized, then you have to reduce your time of resting, trying to accelerate going through that process so you can really offset some of it. But don't get me wrong, it will be hard to accomplish the aiming standards that you will be looking for. So those 2 components are the heart of this process. And obviously from there, on what I call the dry side of the nixtamalization, the first grind is as important. If you happen to have a good, efficiency meal, then you more likely are going to have an efficient consumption of gas on the burner for the flash drying system, and you're obviously going to be able to minimize the runaround through the rest of the line as it's being processed. So if you have a good profile, a low granulation profile from the first grind, more likely you're going to be able to release a lot of the load or the workload of the line into the beans directly. The yield, the process of transformation, just to give you a snapshot of what we're talking, again, between the 3 different milling processes. On the dry milling, at best, you're going to be able to accomplish 75%. It's actually more down to the 71 to 74%. The other 25%, you're obviously going to have a little a loss on moisture, but the rest of it goes to the byproducts, whether it's going into the feed industry or some specialty items. There's another process of separation for the germ from the fiber for the oil production and whatnot. But mainly, you see that there's a big difference between one another. So think about it. At best, you're going to accomplish is 75% yield or of transformation. In the pre-cook, basically you have the same because it's the same processing. Remember, we just put in between a pre-gelatinization system, and then we go back to dehydration, and then we follow like nothing happened. And basically you're going to accomplish about the same. Obviously, the finished good of a pre-gel flour, you know, cornmeal, or, you know, South America, they call it arepa flour. You're going to have a yielding of the finished good production of about 170% yielding. In the nixtamalization, you basically can accomplish up to about 93% on yield. Why? Because you're basically utilizing, and I think that is the main factor and the importance of this process, you know, and the goal to spreading the word about it. You're utilizing the whole corn. You will have losses. Obviously, some of it have to do with the outer part, some of it have to do with the endosperm, but most of this loss has to do with moisture content. Think about that. If you get your corn, let's say somewhere around 15%, 14.5% of your finished flour, it's 10.5%, 11%. You have 4% right there. So the other 3%, it goes through a good portion on the cooking step, the nixtamalization, where there's a lot of you know, starch being released and part of the fiber that we lose throughout the same process. But not all of it, and the more that you can accomplish to stay to it, is the more nutritious your product is going to be. The finished product, you know, in that case, also is one of the highest, achieving around 180% of the flour altogether. So basically, if you think about it, you're basically doubling the amount of the clean corn into finished product, being tortillas, obviously. I mentioned earlier, there are certain products that require lower water absorption, snacks per se. You will not accomplish 180%, but you will still accomplish a substantial number. You might be able, obviously, to accomplish the 93%, maybe a little higher, but you also have to modify the process in order to have low water absorption. Why? Because at the end, a lot of these snacks, they go through a frying process. So think about it as water absorption will convert in oil retention. So, you know, typical snack chip that is gonna be sold out in the little bags for self-consumption, you're looking around 21% oil content. So obviously those flours require a lower capacity. Otherwise, you're gonna be carrying a bag of you know, chips with oil. Some of the highlights of our technology, trying to wrap this up in a way, it's we obviously can offer nowadays 3 different sizes of processing technologies. We go as low as you know, 60 metric tons per day input of clean corn to our line. We can do the 100 metric tons a day incoming corn, which is very much the standard size in the corn, in the masa flour or the nixtamalized corn flour processing. You know, it's a rule of thumb or lines of 100 metric tons per day capacity. And then we obviously have one line that is way bigger, that it helps processors or industrials be far more efficient, having the capacity of up to 160 metric tons per day per line. You can combine lines and obviously double over 300 metric tons and so forth, so on. But mainly the layouts are in those sizing. The grinder that you see here, it's by far one of the leading worldwide grinders that you will find. We have the capacity to accomplish over 55% up to 60% of grinding efficiency or milling efficiency on the first stage. That goes through mesh 60, US mesh 60, which I believe it's 250 microns. And don't think about the retention on top, but what goes through. So it is that efficient. So In other words, over half of your production is released as finished product right from the first pass. It doesn't get any better than that, or there's really nobody that can that today's can compete with that efficiency, you know. Wise. So we're very proud of having that accomplishment, and a lot of these equipments, just like this one alone, in its all constructed in stainless steel. The hammers are heat treated for hardness, you know, and giving more durability, better performance. There's a lot of ways to adjust the space between the hammers and the plates. Inspection and sanitation you know, becomes simpler with a lot of the ways and the gadgets that this grinder has. Also has temperature control for the bearings. It has temperature control for the product output. It has vibration monitoring or sensors in order to assure proper functionality of these products. And the overall, you know, the rest of the equipment in an overall design, we have accomplished as low as under 0.75% of emissions or yield loss for emissions. You're going to lose some on the cooking. Remember that I said that, and that's as it's going through water, there's really not a way to control how much it detaches, which is typically no more than the 2%. You will find, but on the emission side, we are very thorough about controlling on individual filter systems throughout the line, such as the cooling design has its own individual filtering system, and then the rest of the line is completely enclosed. If you might know, hands-on, it's all automated, and it helps you accomplish the most efficiency of the transformation throughout the line. And that basically wraps up the explanation of the technology. Obviously, as I mentioned, the applications mainly worldwide now. You hear of nixtamalized flours or masa flour, as it's also well known in the table tortilla and snack industry. Table tortillas, perhaps in Mexico down to Central America and further south, are the leading product. You know, but if you step into North America, and as it's beginning to grow more acceptance in other countries, Europe and Asia and whatnot, you go into the snack side, it's becoming the leading one. From there, there's another segment for bakery premixes that are taking the lead on the trend. One, corn is very cost effective compared to a lot of the other alternatives. There's always availability of corn. And now they're finding a lot of other applications into it, and specifically for corn flour, because also it's great advantage of nutrition availability behind it. Other advantages that it's well recognized as gluten-free, so for pasta solutions, for extrusion, for extruded products, expanded products, laminated and whatnot. It's also a great solution. And you also use for thickeners, fillers, batters, dusting, as you might find application. There's some industry that uses flours for soup production as thickener, for sauces and whatnot. So it's a great component that, again, it has the whole corn complexity in basically down to flour form. And, you know, just to kind of wrap up, a lot of these benefits goes back around of the importance of the Nixtamalized and why we are so eager to voice out this technology and this processing, because by far you make the most out of your grain or cereal. In this case, obviously the corn. You basically utilize all of it. It will help tremendously that a lot of the countries nowadays that they do the germ and use just basically the starch for their consumption, whether it goes on a meal or a cornmeal or a cake or a, you know, whatever form they might be. Just think about if it's loaded with all those nutrients, and perhaps it also has another extra 20, of the main component. You're going to lose some for moisture, but altogether, the benefits in, the counter benefits also are the nutrient content. It's a great source of fiber, as I had explained. We don't eliminate the fiber intentionally. There's some losses throughout the system, but obviously we aim for to maintain that fiber integrated in the flour. We increase the calcium content, obviously, because we use hydrated lime. Aside of that, the corn itself has a very little content of that. To the point where that calcium and phosphorus content can make, in this case, the tortilla comparable to the milk in some cases. So as far as calcium content goes, increase partially iron and zinc and other minerals. And it also helps reduce issues that we've seen throughout the history of life as pellagra. Because of the lack of availability of niacin or vitamin B3. It's a great source of it. And obviously, another great advantage is the reduction of the mycotoxins. A lot of countries are struggling to figure how to eliminate that because it's some of the conditions that they have to harvest, through and produce their corn. In the form of the nixtamal, after you're looking at the stages of the process, in the nixtamal, you basically have the amylose to about 85% of its initial complexity. Essential amino acids are around 70 to 100%. Calcium goes to 5 times its original form. You still hold raw fiber about 51% of its original form, as well as the oil. They still have 71% of the oils as content. The dietary fiber insoluble goes to 40 to 90%, depending on how well you cook or nixtamalize your kernels. The iron basically doubles. The zinc stays the same and becomes obviously available. Niacin goes to about 52% of its original form. The phytic acid goes down to 60 to 84%, and the proteins basically remain the same. The masa, as we know, or the dough, basically, in the case of yellow corn, you have about 125% content of B-carotenes. Anthocyanins, for blue corn, you have a little under 30%. Calcium, you can reach up to 4 times its original form. You still have 33% of raw fibers. You have about half of the oil content. Essential amino acids to 100%. Iron stays about 63%, protein 98%, and provitamin A goes to 80 to 100%. Finished product, basically, you have the complexity of maintaining anthocyanins just under 32%, calcium up to 30 times, basically. And that, let me just tell you, in a lot of the cultures or societies, call it in Mexico, they used to add lime after this process for the production of tortillas or finished goods. That's a cultural thing. Not all of the industry does that. That enhances yet the flavor of the tortilla and extends some of the shelf life as well, and makes it a little more unique for certain regions. So that's why you see it can really go escalate to 30 times, its original form. Essential amino acids are 80 to 100%. Oils back to about half, a little over half, 55%. Proteins, you're running between the 85 to 90%. And carotenes or provitamins are staying around 80 to 100%. You have resistant starches, or actually a lot of the endosperm becomes more resistant. So basically, that's why you see that increases for another 50% over the original. And finally, the zinc, it's also increased another 50% of its original form. And that's where I said that a lot of nutrients become available and for human consumption. A lot of this information obviously was provided by CIMIT, which I want to also extend the thanks. And you can reach out to them. It's a non-profit organization across the world that helps the improvement of corn and wheat. And they've done a lot of scientific work when it comes to understanding processing. And they're also a huge voice for nixtamalization. Obviously, I prefer them because obviously we're on the other side, we're on the technology side. So when it comes to asking for solutions, just feel free to reach out to us, and we'll definitely be happy to help you guys and look forward to working with you all. Obviously, I think I have to pass the baton back to Andrea and maybe get to see some of the questions so we can give you some of the answers for sure. I don't know if I run good on time, Andrea.
Perfect. Excellent. Excellent, Rodrigo. Excellent. And congratulations. We've got a question from Jonathan Aves. He wanted to intervene. So Jonathan, you can join if you want.
Jonathan has the microphone off right now. While he fixes that, I'll tell you, I'm reading a question, another question that it says, in terms of timing, how long can the nixtamalization process take? That's a great question, and I'm sorry I probably didn't get much into the recipe side of the processing, but perhaps I'll explain you real quick. Typically, you find the nixtamalization process to take between 30 to 50 minutes. And we're talking temperature somewhere rather 85 Celsius on both sides of the cooking system, on the entry and the exit. Basically, I mentioned, if you might remember, low absorption flours. You can go lower than the 30 minutes, maybe 25, 28 minutes you can accomplish that. Obviously, you're going to reduce less than a fourth of the time the steeping. Like I said, half an hour to an hour per se instead of the 4 hours. So that's where you reduce the retention time, not just on the cooking system, but also on the steeping part. But it depends on the product that you're aiming for. Very typically, just think about 30 to 50 minutes, temperature from 80 to 90 degrees. And can Jonathan make the question, or should I move to the next one?
No, I think probably Jonathan, I don't know. No, he didn't.
It doesn't have his microphone on. He might be having a little troubles with that. And Jonathan, if you can hear us, you can always just write it down on the chat part, the questions and answers tool that you see also on your screen. There's another question from Tennessee. Hi there. Well, this goes, I think, for Andrea, or we'll see the specific energy consumption, including also thermal energy. It kind of varies. Obviously, if you want kind of a rule of thumb for energy consumption, electricity speaking, we're talking somewhere rather 120 to 130 kilowatt hour per metric ton being produced. I don't know if you're used to metric system, but you can use that as a reference. And energy or call it MMBTUs as far as natural gas as being the driver for the heat. You obviously can go as low as 600 megacalories per metric ton, or let's say 2.5 MMBTUs per se. Depends on the sizing, and also, again, depends a lot in the product that you're aiming for. So a low water absorption flour will require less heat, less temperature on the cooking, less heat on the dehydrator or flash dryer system. So you might be able to go right on the 100 and 110 kilowatts, and you might be able to get away with no more than 2 MBTUs, of natural gas. But again, if you're going through the typical regular masa flour, nixtamalized flour for table tortillas, as we call, you're going to be on the first indicators that I've given you.
Okay, we got
there's a great question. I'm sorry, Andrea. Let me just read this one. It's very interesting. It says, can you nixtamalize the finished product of corn, which we call meal, in South Africa? The quick answer is yes, and perhaps that's one of the best examples that I can take advantage of the question right now. In Africa, and the majority, in most of the consumption for human consumption, these products are degermed. So think about that, you not have a full unit of corn, but you only have about 74% of it, of cornmeal, if you might. Well, think about that, you can increase that back to the full unit, the full kilogram or metric ton of corn, nixtamalized, and on top of it, you add all the availability of those nutrients. So that's one of the great benefits of converting a lot of the world way of processing into nixtamalization, because you can solve a lot of nutritional opportunities, as well as other countries, the direct access from a very ancestral recipe of way of processing, very natural, very unique. You don't have to add more vitamins or anything else. In a lot of the cases, they use adding different extra vitamins just by mandates of government or whatnot, because they don't have those in the other sources of food. So they use the flour as the driver to help in other terms. But it's as clean as it gets. And I'm sorry, Andrea.
No, Rodrigo, it's your turn. It's your turn to speak. So,
And
do we have any other question? Jonathan didn't connect. And I got a question, Rodrigo, that I got from a customer, that is pretty interesting. He's got pre-cooked flour. He's got a pre-cooked flour. Pre-cooked cornmeal, South America, and he asked me what he needed to do to turn it into to add a nixtamalization line. So I know the answer, but I think it can be interesting for everybody attending, to discuss this matter.
Yes. So perhaps a lot up to your answer. In a lot of the cases, you can, and that's also a very justifiable question. In some industrials that do already have a processing, let's say if we're approached by a company that has a dry mill or a pre-gel mill, and they say like, can we work nixtamalization into the same processing, basically in parallel, or adapt the portion of the nixtamalization? Yes, it can be accomplished. So yes, in many ways, you can take advantage of what you already have. We typically offer to do for a technical visit, part of our engineering team also, so we can scale and size and evaluate what parts might work, and how we can accommodate part of the technology. So you not necessarily have to start from scratch. You can adapt to what you might already have. I think that's where the question lays to. And obviously, it's not just about adding lime as an ingredient per se to the cornmeal. It doesn't work that way. There's been a lot of work in good way, although a little waste of time, into trying to add lime as an ingredient instead of following the process of nixtamalization. Remember, I mentioned it several times, nixtamalization, it's a physical-chemical processing of the whole corn. So you gotta have all those factors, and I'm not talking, in this case, we're just gonna nixtamalize the starch or the grit. You're missing everything else. It's not gonna have the same effect. It's not gonna have the nutrients. It's not gonna have the playability, resistance, and all the attributes that the masa dough does have. So yes, the answer is obviously yes, and I'm sure Andrea.
No, absolutely, absolutely. It's very interesting, and I guess it's going to be of interest for everybody. And here, Rodrigo, we got an anonymous spectator. What about the degelatinized flour obtained during nixtamal process?
Can you please repeat that question, Andrea? I just kind of didn't understand the context of the question.
What about degelatinized flour obtained during nixtamal process?
Well, I guess it doesn't really specify about what are they trying to aim the question for, but if you look into the corn going through the nixtamalization process, you're gonna find out, if you were to break it apart or break it in two, that you're only gelatinizing about half of the endosperm. So you're aiming for to leave the inner half untouched. You're obviously just aiming for to gelatinize the outer half of the endosperm. I'm not talking about the layer, I'm not talking about the germ, I'm talking about the starch itself. So roughly, rule of thumb, it's 50% of the starch accomplished being gelatinized. And then again, you might want to have lower absorption water flours or higher water absorption, as far as characteristics, but as a rule of thumb, that's what you accomplish. The rest that goes on, it's on the steeping side, that you just help your kernels there for a period of time, and that softens. That doesn't necessarily gelatinize, but soften, make them easier to work with. But as a quick reference, we're talking 50-50, gelatinized and ungelatinized.
Very interesting, Rodrigo. And then we got the last question for today, which still from Tanase. And this is a very interesting question, I guess. I think that it interests everybody, because Tanase is asking if the used water needs some special treatment after leaving the process. Is there any dangerous component for the environment? I think this is very interesting for everybody, and a really up-to-date question.
Yes, there's a great myth of water from nixtamalization being a contaminant. Obviously, the biggest challenge of that processed water we know as nehayote is basically the BOD's content. So basically, the amount of oxygen that you need to oxidize, and excuse my redundance, the water to release. The only content there is on the wastewater is basically solids of corn and the residual of lime. So those are indeed not contaminants, but it can become a little challenging in some cases to treat. And obviously, there's areas where you don't really need to treat. You can do land application. It depends on the sites, on the places, on the governmental regulations. If you're going into the main sewage, if you're in the middle of a big city, or if you're on the rural sites. I have had the experience of land applying to soils that do have a low pH. Basically, so adding the wastewater or the nehayote back into those fields will actually help the growers to offset that low pH and start preparing their lands for the proper pH for when it comes to planting. There's obviously studies from different universities, one of it being the University of Iowa, or actually Iowa State University, I'm sorry. They have a very interesting research accomplished showing that this, call it wastewater or nehayote, can be even used for feed application. There's nutrients on that water. There's actually content of ferulic acid and some other, nutrients that can be good for consuming. Obviously, when you look at it from the numbers standpoint, it might not be cost effective to transport the wastewater to the cattle feed farms, but indeed there's very different ways that you can tackle. And obviously, we continue to work on technologies to unveil a very low water consumption system. So what I had presented is the traditional system. Perhaps on the very near future, we're gonna hope to have the opportunity to also, along with Andrea and the whole team of Ocrim, be able to present a sustainable solution, to the industry. It also makes it very appealable, where you reduce or eliminate 100% of that wastewater.
Thank you very much, Rodrigo, and thank you very much to everybody to participate on this webinar. And well, if you got any other question,
I didn't get to type any of the answers. I see we have the capability to type in the answers. Obviously, I encourage and invite everyone to send more questions throughout via email.
The form via email.
Exactly, and make contact with your sales reps as well. We'll be more than happy to help you guys and answer any doubts. Indeed, there's a lot of unanswered questions out there, or lack of knowledge, and that's by far the goal of this webinar. I do thank you, Andrea, for the opportunity of working along with you and the great team of Ocrim. I appreciate the opportunity, and I do hope that we make justice for everyone's time.
Absolutely, absolutely. Thank you very much, Rodrigo, and everybody at Molitecnica. And thank you very much. We appreciate it. And thanks everybody for taking part in this webinar. And we look forward to seeing you very soon, and be in touch. Have a nice day. Bye, everybody.
Great. Thank you. Bye-bye.